Hi everyone, this is John Wan. In today's video, I'm going to go through the project update on course CSC8710 for this winter semester. Our project is about distributed neural network cross-validation in DataView CUDA workflow in GPU cluster. So the team member including me and Ziyun Xiao. We're targeting to distribute a 5-fold cross-validation on GPU cluster in order to pick up the best architecture from 3 different architectures. For example, we can have first one as 4 layers, the second one has 10 layers, and third one has 5 layers. So we're trying to use this cross-validation to pick up the best one, and then we can use that architecture to conduct the training process. So a little bit review on the hardware we are going to use, which is a Jetson Nano system as well as a Jetson Xavier NX system. So they both contains CPU and GPU, which includes some CUDA cores that are needed for the new network. So here is a challenge. For the first one, to set up the proper cluster of GPU environment to conduct the parallel training on the new network. This has been done and we can review this soon. And for the second and third item, which is to dispatch proper dataset from DataView to different nodes in cluster to carry out the training and testing process. And this one is in progress right now. And also to carry out necessary messaging passing among nodes. So we're trying to use a CUDA-aware MPI. That means we are able to transfer the data from the GPU to GPU, not only from GPU to host and host to GPU. So while combining the MPI and CUDA, we need to send the GPU buffers instead of the host buffers. Without the CUDA-aware MPI, we will stage a buffer from GPU to host and then host to GPU. So that is a kind of loop. And here is a screenshot of the current cluster setup. So you can see we have 6 nodes, and which has 4 Jetson Nano and 2 Jetson Xavier system. So we have already configured them one by one, and we installed the Ubuntu 18.04.4 LTS OS. And we also set up the static IP on each one of them, as well as we set up the MPI among the nodes, so we enable them to communicate with each other. So here is a project status. For the first one, we are able to run a sample CUDA MPI square root method across the nodes in a map and reduce way. So maybe we can take a look at this code very briefly. So here is a makefile. We are going to have 2 files basically from this project. First one is a CPP file. We're going to compile into a .o file. And then we have a CUDA file. We also will compile this one into the .o file. And this makefile will help us to save some time when we just make a little change on one of the file. We don't need to compile the whole project again. So here you can see the whole project is need these 2 compilation files. And after we get this simple MPI, we're going to run that on the different nodes. This is in a map reduce way because we're going to have the several nodes. For the root nodes, we're going to generate some data randomly. So here is a code to generate the root data randomly. So here you can see the data size per node is equals to grid size times the block size. Here is a grid size and block size, and that means every node will receive this amount of data, and we generate certain amount of data based on the nodes we have, and then we distribute them into each node by using the MPI scatter. And after that, we delete the data from the root, as well as we conduct the square root computation on each one of them using the GPU. After that, we do the summation. That means we're doing the reduce to reduce the data to the root nodes. After that, we print out this is done. So if we take a look at the here is a terminal, and I can try to run this one briefly. So you can see on the left top here is one of the nodes, which is Jetson Xavier NX. This is a root node, and at the bottom left here is one of the slave nodes, and which is Jetson Nano. And also here is another one, Jetson Nano. So here, let me go back to the previous layer, and here we can see we have two folders. First one is a simple MPI, so this is something we're going to run because we have already compiled the whole project using the make file. After we make this executable file, we have to copy it to every nodes, and this has all been done. So right now we are able to just run the project. And here we are going to specify a host file, which is going to specify which nodes we are going to take. For the testing purpose, we will only use 3 of them. So if we check the GPU utilization, and while we run, you will notice that soon we are going to utilize the GPU. You can see this is a GPU utilization on each one of them. Because the Jetson Xavier is a little bit powerful, we are going to assign a little more workloads on this one. So you can see they have comparable execution time. That is a experiment we have done. So that means we're at least can use some distribution to distribute our work among the different GPU nodes. So that is good to know. And the second step I'm working on is to compile the CUDA Neural Network project I'm working on in another thread, which is able to take any arbitrary architecture, and then we can train and test in the model. And I'm able to compile the whole project into a .out executable file, which is able to run on the Windows machine. This is a test proof that codes are working fine, because we don't want to have some buggy code and send to the Jetson and to let it compile, but we have many unresolvable errors to pop up. So here, currently I'm working on to distribute different numbers of epochs. For example, here is a code. Here you can see the makefile is a lot more complicated from the previous one. So if we take a look at the CUDA MPI, so here, based on how many nodes we have, we will randomly generate an array from each value is from 250 to 550. So basically, we are going to randomly generate how many epochs will be run on each node. So here, we are going to distribute this value to each node, and each node will receive that to carry out the main test with this value. So the main test is residing to this CUDA file, and basically you will take how many iterations or how many epochs you are going to take with the same size of data set and with the same architecture for now. So I think this is a good start. So after that, we are going to compile the whole project into a single executable. If we take a look at the folder, which is called distribute CUDA Neural Network, so here I've already compiled all the single files into a .o. So that means in the make file, we've already achieved all the steps except the last one. So if we try to make the file, so you can see make, and we will return some error. That is the last step, which is to compile the whole project or link the whole compilation files into a single executable. But right now I have some error, the undefined reference to the method I'm going to call from the CUDA file. So I think this still be some time to debug this error and try to fix that. But I think after that, maybe that's another milestone for this project to move forward, because we know we are able to distribute CUDA programs and with customizable data as well as a specification, and we are going to run on different nodes, so that can help us to explore as much as possibilities on these projects. So I think that's pretty much of the status for now. So hopefully we can move that more faster afterwards. And thank you so much for your time. Hope you enjoy. Until next time, happy coding.